Hello guys, and welcome back to my YouTube channel. In today's video, I'll be going over some internal structures of the cranium. So right off the bat, and I'm going to zoom in a little bit for you so that you can appreciate this structure over here. We call that the crista galli. The crista galli is a landmark that pertains to the ethmoid bone. This is a really important structure because this is the site of attachment for those meninges. And the meninges are a covering. They're these layers that cover the brain, and they attach anteriorly at this crista galli. That semi-triangular weird shape, we call that cribriform plate. And the cribriform plate, and I'm just going to zoom in further for you. The cribriform plate has openings, and we call those olfactory foramina. It's the olfactory nerve that has a lot of branches that are going to go through those openings. And just as an FYI, the olfactory nerve, cranial nerve number 1, is going to allow us for the sense of smell. So again, crista galli, the cribriform plate, and the openings olfactory foramina. Anterior to this, I hope you can see this very small opening, and it's right there. We call that the foramen cecum. Now, this is a really important anatomical structure because this is going to house one of the veins that actually has a connection with some drainage from the brain. So clinically, it's significant because we don't want anybody to get sick for a long time, because there could be a chance that some bacteria can crawl up and make its way up to the brain and cause meningitis or some sort of those diseases that we don't want. So if I go ahead and zoom out for you, right over here, this top butterfly, and I hope you see that whatever I'm outlining, you're following. All of that's the sphenoid bone. And the sphenoid bone has parts to it. This upper part, that's called the lesser wing of the sphenoid bone. As I mentioned before in my videos, lesser means smaller. And you have the greater wing, and the greater wing just means bigger. This region right here, it's a very important region. This collectively is known as the sella turcica. The sella turcica is translated into a Turkish saddle. And the sella turcica has parts to it. The first part is the anterior clinoid process, or processes, because it's more than one. The anterior clinoid process is this one and this one. So if I were to poke this, those are the anterior clinoid processes. And I'm just going to zoom in a little bit for you. Posterior, you have the posterior clinoid process. So if you pinch that, that's the posterior clinoid process. All of this right here, this wall, we call that the dorsum SELLAE, and anterior to that, you have the tuberculum SELLAE. So tuberculum SELLAE, dorsum SELLAE, anterior clinoid process, posterior clinoid process. And number 94 that you see right there, if you see a sticker right there, we call that the hypophyseal fossa. This structure anatomically is very significant because it houses the pituitary gland, and it's protected by all these structures around it. So if you want to think about my hand, my fist being the pituitary gland, and this being that shallow depression, it's going to fit like very, very tight and snug. And that's the main function. This actually houses that pituitary gland for you. This right here, right off the bat, we call that's the foramen lacerum. And they're the most medial openings. So from the midline, the first openings off to the side, those are the foramen lacerum. Right here, I know you can't really see this on this model, but you have one opening right there, another one, and another one. The way that you can remember these three is by ROS. R-O-S. Foramen rotundum, foramen ovale, and foramen spinosum. R-O-S. ROS. So we go posterior and we see this big one. This one you can't miss. We call that foramen magnum. That's really, really big. 93, you see this kind of like elevated portion. Somewhat, if I could just go ahead and pinch this. Sorry about that. If I can go ahead and pinch this. This kind of looks like irregular mountains, if you want to see it that way. This is called the petrous part or the petrous portion, and it pertains to the temporal bone. So we say the petrous portion of the temporal bone. The main significance of the petrous portion of the temporal bone is that it houses the 3 ear ossicles. Ossicles just refers to little bone. And those 3 ear ossicles, they work together for you to actually get a sense of what a sound is. The acronym is MIS, M-I-S, which stands for Malleus, Incus, and Stapes. This opening, we call that the internal acoustic meatus or the internal auditory canal. Right here, external is referring to the outside. That's the external acoustic meatus or external auditory canal. So the external is on the outside, the internal, take a look, right on the inside. These are called jugular foramen or foramen jugular. It depends on your professor. Flip this way so that you can appreciate 95 is pointing to this little bump. The bump that's called the internal occipital protuberance. A protuberance is like a bump. So you have the internal occipital protuberance, and it follows as the internal occipital crest. Now, these structures are very important because, again, it's going to anchor those meninges, but it anchors it posteriorly. Anterior, I said earlier in this video that it anchors at the crista galli, while posterior over here. Take a look. Now, I'm going to flip this such a way that you're looking at an inferior view. Right off the bat, you can see this irregular mass, and we call that the mastoid process. The mastoid process looks like an irregular mass. Now, at this point, you're probably saying everything looks like an irregular mass, but mastoid process. Take a look. This one, that's the styloid process. The styloid process looks like a stylus pen. So styloid process, mastoid process. In between, you have the stylomastoid foramen. A foramen is that opening. And I'm going to zoom in a little bit for you so you can appreciate this one more time. So you have the mastoid process, the styloid process, and the stylomastoid foramen. All right, now that we're here, let's get to 97. This right here, this smooth surface, this is called the occipital condyle. A condyle it's a smooth surface right here. Just inferior to the occipital condyles, you have the condylar canals, also known as the condyloid canals. Now, my model doesn't allow me to actually go through with the probe, but these right here are canals, and we call those the condyloid canals or condylar canals. Internally, and you can't see it, but just so you know, you also have the hypoglossal canal, and they're somewhat just under the occipital condyle, so you have to put the stick through. But again, my model doesn't go through. As we further go anterior, you see these gummies right here. We call that the mandibular fossa. That's the mandibular fossa. Some anatomical models don't have the gummies, which is good. Mine have it, so yours may or may not have it. So let's focus right here on these little guys. This one, this is called the medial pterygoid plate, and off to the sides, you have the lateral pterygoid plate. They also go by medial pterygoid process and lateral pterygoid process. These landmarks, the medial and lateral pterygoid plates, pertain to the sphenoid bone. This bone right in the middle, I hope you can see that, we call that the VOMER. That's the VOMER. All right. So 96, if your professor is asking you to name all of this landmark, we call that the palatine process of the maxilla. If she asks you for the bone, then it's just the maxilla. The maxilla makes roughly 2/3 of the face. So all of this big chunk, that's the maxilla. And it actually comes down and it goes posterior. It actually deeps into your mouth. So what you're looking at here, that's an extension up to here. That's an extension of that maxilla. And that's why this is known as the palatine process of the maxilla. And it makes 2/3 of this roof of the mouth. That last 1/3 is made by this landmark that's called the horizontal plate of the palatine bone. All of that, that's the horizontal plate of the palatine bone. And it's in here where you have these openings, and I'm going to zoom in for you, that greater and lesser palatine foramina. And that's going to allow for blood vessels and nerves to pass through. So going back here, that right there, and I'm going to flip this for you so that you're looking at a different view. This opening, that's called the incisive canal. So incisive canal, palatine process of the maxilla, horizontal plate of the palatine bone. These two structures are going to create the bony palate or the hard palate. So if you go ahead, and please don't do it, but if you go ahead and take your thumbs and introduce them into your mouth and you press against that palate, you're going to feel that it's all bone. And that hard palate is made out of these two bones, that palatine process of the maxilla and the horizontal plate of the palatine bone. Then the hard plate becomes soft tissue, and we call that the soft palate. Going back to this view, I hope you can appreciate that. So these right here, they're like little raised bumps. We call that superciliary arches. Now, the superciliary arches are more dominant in the phallus. And they're somewhat of your eyebrows. That's where your eyebrows are going to sit. So superciliary arches right there. Smack in the middle, we have the glabella. That's the glabella. So if you take your finger and you put it in between your eyebrows, that's the glabella. All of this, we call that the supraorbital margin. And this is the supraorbital foramen. Supra, the prefix supra means above. So orbital refers to the orbit, which is the eye. So supraorbital foramen sometimes it's also referred as the supraorbital notch, which is still good. And you have this one at the bottom, which is the infraorbital foramen. And the infra, the word infra, the prefix infra refers to below. So you have a supra, which is above, and an infra, which is below. I hope that kind of made sense. If I go ahead and zoom in for you, I'm zooming in for you, you have these two slits. The one at the top, we call that the superior orbital fissure and the inferior orbital fissure. Now there is a canal. I hope you can see that. My probe doesn't go through because it's too thick, but just know that if it would go through, that's the optic canal. So optic canal, superior orbital fissure, inferior orbital fissure. And it's a bilateral structure, meaning that it's found on both sides right there. Let's take a look at this structure, which is really, really important. This right here, this is the nasal septum. Septum refers to a partition or a wall. So the bony septum of your nose is made out of two bones. The first upper half, all of this upper half, it's made out of perpendicular plate of the ethmoid bone, while this lower half is made by the vomer. Now, this model doesn't really show you. You can see the inferior nasal concha, which is, it's just a bone by itself, and the middle nasal concha, which pertains to the ethmoid. And you don't see the superior nasal concha because it's too high at the top. But just so you know, the superior and middle nasal concha pertain to the ethmoid bone, while the inferior nasal concha is just a bone by itself. I hope that made sense. So, this lateral view, take a look. This, commonly known as your cheekbones, we call that zygoma or the zygomatic bone. The zygomatic bone is going to have a little projection. And we call that the temporal process of the zygomatic bone. And the reason why we call that is because we name it after its articulation. This is the zygomatic process of the temporal bone. So an analogy that I always like to give is think of this as a whole bridge. And that bridge is composed of two parts. The first part is the zygomatic process of the temporal bone, and the other half is the temporal process of the zygomatic bone. Collectively, the whole bridge together is known as the zygomatic arch. I want to make this video just really short, but I hope it helped you. And don't forget to like and subscribe and leave a comment down below if you have any other questions. And God bless.